Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is handling of typical deviations in API manufacturing. The ICH Q7 recommends in several sections to initiate a deviation investigation to find out the root cause of the deviation. There is a reference in ICH-Q7 in sections 2.16, 5.14, 5.35, 6.53, 8.14, 8.15 and 8.20 to investigate the deviations for the reasons for failure. Section 2.16 specifically recommends any deviation from established procedures should be documented and explained. Critical deviations should be investigated and the investigation and its conclusions should be documented. Also, section 6.53 says written procedures should be established and followed for investigating critical deviations or the failure of a batch of intermediate or API to meet the specifications. So it is very important to see that the deviations are investigated for the root cause. This is the requirement as per the ICH Q7. Let us try to understand more on this on some typical deviation examples. Let us see some typical deviations and its investigation. One example is the batch failed in impurity A with a value of 0.2% against the specification of not more than 0.1%. The initial review of the data generated indicated that the total impurity level was within the specification of not more than 0.5%. Other impurities B, C and D are within the specifications. And how do you investigate? Your approach to investigate into the root cause largely depends on understanding the deviation in full. Let us see this example. Impurity A alone failed to meet the specification. Other impurities are within the limits. Also, there is no issue with the total impurities. You start the investigation on the trends of other impurities and the total impurities. If there is no out of trend results observed, then the contamination of glassware may not be the root cause of failure. Of course, this has to be negated in the OOS investigation anyway. Proper functioning of equipment also should be confirmed by checking the compliance to system suitability parameters. The focus should be on potential source of impurity A. So you have to investigate from which input raw material this impurity is coming into the product. Let us assume that this impurity A is a degradation product or a process impurity from a particular raw material used in the process. Then move on to the source of that raw material. Check if it was procured from the same approved vendor or from a different supplier. If it is a different source, you have to check what is the route of synthesis, that is ROS of that supplier. What is the impurities trend of supply of that particular vendor material? Focus more on the trends of impurity A. This route of investigation will provide a very useful data. Depending upon the reaction mechanism of formation of impurity A in the process conditions, maybe the next step of investigation, the temperature, pH, etc. of the reaction mass could be a cause for increased level of impurity A. This has to be discussed with R&D team for finding out the reasons for increase. Certain impurities may not be removed because of incomplete or improper washing of the product cake in the centrifuge. This also should be a part of investigation. So the investigation should look into the washing operations also. In several cases, drying operations also could significantly contribute to increase of impurities. It is necessary to confirm whether there was any excessive drying that could have caused the increase of impurity A. So the investigation should revolve around the actual culprit of the failure. Let us see another example. Residual solvents test did not pass on the product while the batch was tested for final release. The values were more than 50% of the acceptable limits of ICH. Some information on this particular deviation is the batch was dried in a tray dryer, milled and packaged in the last stage of the process. This is the information. Initially, the laboratory OS investigation should include checking the validity of the standards, preparation of standards, including the weights taken for the standards for preparation, glassware used, compliance to system suitability parameters. Since the residual solvents are being analyzed by using headspace analyzer, the investigation should focus on the potential leaks in the headspace system. All these parameters have to be checked and documented with details of what exactly the observations were. Then in phase 2 investigation, main aspect of investigation should include the drying operation. Mostly drying operation is the last operation of the process before taking for milling and packaging. Investigate whether there was any uneven heating in the dryer. This is quite possible when the tray dryer is used. This may not be a possibility for a rotocone vacuum dryer, that is RVD. Uniformity of drying is more in this type of dryers. Here it is necessary to look into the drying trend of the product. Was it dried within the normal time frame, like 6 hours or 8 hours as per the batch record? If not, the operation of the dryer is the culprit for failure. Generally, a water content test or a loss on drying test is considered as in-process checkpoint for completion of drying. Check whether the in-process checkpoint was within limits. Sampling of in-process samples from different locations, say top, middle and bottom of the trays, to be representative. The investigation should definitely focus on this aspect also. Go one more step backwards. The drying time depends also on the wetness of the cake unloaded from the centrifuge, which goes for drying. So the investigation should focus on the aspect and check whether or not the centrifuge was spun properly to achieve the target wetness for the cake. If not, the investigation should focus on the performance of the centrifuge too. By now, it is certain that the culprit could be caught. This is how the investigation should go on. The focus should be concentrated on the potential root cause to get more successful investigation output. Let us see yet another example. Wrong batch number was printed on the finished product labels. Some information regarding this deviation is this was noticed by routine but unwritten experience of the operator when the labeling operation or the finished product containers started. Wrong batch number was printed on the finished product labels. This is really a serious deviation. Let us accumulate all possibilities of failure. The investigation should start to look into with the effectiveness of the system. The system has to be investigated first by checking the communication system for batch numbering printing on the label. Who generates the communication and the batch number? How is it controlled, monitored to get the finished product labels? Next step of the investigation should be on the label printing software. Is the software capable of tracing the batch numbers printed so far on the printer? And is there any pop-up to check the correctness of the batch number information on the labels? For any repeat batch numbers or for entry of any random batch numbers, is the batch number format is fixed and cannot be altered without authorization? Is the authorized person operating the printer? You may have to include in the investigation into checking at various levels of for confirmation of correctness of the information on the label. On several incidences, in informal chats, discussion with the shop floor operator provides useful information to find out the system slips. This also can become a part of investigation. In any of these focus points, the root cause of the failure can easily be established. If FTA, the fault tree analysis tool of Q9, is understood well, it is easier to capture all these critical observations of investigation to get a meaningful outcome of deviations, which will lead to recommend a kappa to avoid such types of deviations. Depending upon the significance of deviation, it can be classified as major or minor. However, for all such investigations, it is necessary to have a team from production, R&D and QC departments because the data and information are required from all these functions as required. QA person may be selected as a coordinator or the team leader. The fishbone diagram may be useful for capturing the data. The investigation questions should lead to an answer. Just yes or no answers are not adequate for such investigations. I hope that you got a good insight into the handling of deviation investigations very well. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.